Let the Fourier transform of the signal be written in the rectangular form as x e to the power j omega is it? Find the signal yn corresponding to the Fourier transform. This is okay. We are given the signal xn, and it is also given that it can be written in this form. Suppose we are writing its Fourier transform in this form a omega plus j b omega. Then you have to find the Fourier find the signal yn corresponding to this Fourier transform. A omega into e to the power j omega. Okay. What is this? If you are writing this, can we say that AF omega is the real part of x of e to the power j omega?
Yes, sir.
But real part, isn't it? A omega is what? So in terms of x of e to the power j omega, can we write it as x of e to the power j omega plus x star e to the power minus j omega by 2? That is the real, a omega is the real part of x of e to the power j omega. Is it? What is the signal corresponding to this? What is the inverse Fourier transform of this? Inverse Fourier transform. Inverse, let me write it as inverse discrete time Fourier transform. What is that? What is the inverse Fourier transform of x j omega by 2, e to the power j omega by 2?
Stick to xn by 2.
It is xn by 2 plus, what is the property? Remember the
X star n
conjugation
xn by
property.
2.
X star n is what? X star n is x star e to the power minus j omega, isn't it? Is it? Sorry, this is plus. If you want to take the real part of x of e to the power j omega, this is plus, isn't it? Is it?
Yes, sir.
Now tell me what is the second part? Inverse Fourier transform of this. Inverse Fourier transform of x star e to the power minus j omega is x star n. Now what is the inverse Fourier transform of x star e to the power j omega?
X star minus n by 2.
X star minus n by 2. Okay. What type of signal is this?
Real.
Sorry?
Real.
Real. It is a real valued signal. So is it even part of xn?
Yes, sir.
Or I'm simply writing it as xen. That is even part of xn. Inverse Fourier transform of AF omega is xen. Now what about, can you tell me what is the inverse Fourier transform of BF omega?
What part of xn?
Divided by j.
By j. Isn't it? Odd part of xn by j. Okay. Now the question is to find the inverse Fourier transform of this. So what is it? There are two parts, b omega plus a omega into e to the power j omega. What is the inverse Fourier transform? So what is, we can write yn is equal to inverse. What is the inverse Fourier transform of this b of omega? Is it this? You have to find this is y of e to the power j omega is given. The question is to find the inverse Fourier transform of this. And we already got the inverse Fourier transform of b of omega. So it is x naught n by j What about the second part? What is the inverse Fourier transform of a omega into e to the power j omega?
Shifted x.
What shifted? Plus
One
xc.
part of xn plus 1.
What part? This is even part, right? N plus or minus 1?
minus.
Minus or plus? What is the property? It is plus 1, isn't it? Okay, plus if it okay, minus. Is it plus or minus 1? What is the property? Xn minus n naught is e to the power minus. It is plus, isn't it? Xen plus 1. Okay. Now you are given the signal xn, you can find the odd part, even part. Find this, you'll get the answer. Okay. I can give you the answer, you can verify it later on. Let me check whether I have the answer. Which question is that? 16, 15, 16. Yeah, this is the answer. Okay. So this is minus j into this one, and then there is another term plus 2 delta n plus 1. Okay, this is the answer. This is minus j times this plus 2 this one. Okay, do we all other values are 0. This is x of e to the power j. Sorry, this is xn, right? This is xn. Signal xn is given. The first part is what is x of e to the power j0? What is that? X e to the power j0? But what is x e to the power j0? I think we have solved similar questions
Average one.
related. Is it 0? Well, how is it related with xn?
Summation xn.
Is it 2 pi into with this? This is 0. And what about this one, phase angle of x e to the power j omega? So I think we have discussed similar problem related to continuous time Fourier transform, right? When you shift the signal, there is some symmetry. From that, we find the phase angle. Is it? So if you shift the signal, will you get some symmetry, whether you get some even or odd signal?
Shifting right, we get odd signal.
Shifting?
Right by 2.
Shifting right by 2 or left by 2?
Yeah, sorry. Left by 2.
Left.
Shift left by 2. That is, if you consider xn plus 2, xn plus 2 is what? Let's say this is x1n. It is real and odd. That means x1 e to the power j omega. What is the phase angle of that? What is the property? If it is real and even, Fourier transform is real and even. If it is real and odd, Fourier transform is real. Real and purely purely imaginary and odd. That is the property. So what is the, if this is real and odd, what is the Fourier this one? If it is purely imaginary, then what is the phase angle?
Pi by 2.
It is pi by 2. This is pi by 2. Now what is this phase angle? How are the related phase angle of x e to the power j omega and x1 e to the power j omega? If this is the relation in the time domain, what is the relation? Is it x e to the power j omega into e to the power j omega n, e to the power j2 omega is equal to x1 e to the power j omega? Is it the relation in the, if you take the Fourier transform on both sides, will you get this relation?
Yes, sir.
Now, what is the relation between the phase angle? Suppose this is the phase angle of x of e to the power j omega. What is the phase angle of this?
2 omega.
Plus 2 omega is equal to what? Is it pi by 2? By pi by 2, because we are given that it is pi by 2, because if you shift it, you will get an real and odd signal. So it is pi by 2. So what is the answer? Is it pi by 2 minus 2 omega? Is it the answer?
Yes, sir.
Okay, third part is Parseval's theorem, Parseval's theorem. And what about this? Integral minus pi to pi x e to the power j omega e to the power j3 omega d omega. Let me write this. X1 is 1 upon 2 pi integration from minus pi to pi x e to the power j omega e to the power j omega n d omega. This is the inverse Fourier integral. Now tell me, compare these two. How is it related with xn?
2 pi x3.
It is 2 pi x3, isn't it? Here x3 is minus 1, so the answer is minus 2 pi. Is it? It is minus 2 pi. Now what about this? E part. What is the inverse Fourier transform of real part of e to the power j omega into x of e to the power j omega? What is the inverse Fourier transform of real part of x e to the power j omega? If xn is real, its inverse Fourier transform is what?
Even part of x.
It is even part of x. Xen, isn't it? Now what is the real part of x of what? E to the power 2j omega into x e to the power j omega. It is even part of what? Even part of
xn plus 2.
xn plus 2, isn't it? It is even part of xn plus 2. Tell me what is the answer? If you shift the xn plus 2 means you shift it left by 0, left by 2, you will get an odd signal. Even part of an odd signal is what?
0.
0.
0.